Hello, everyone. It is Sunday, and we're going to have a little fun today. Today, we're going to take a look at some of the other channels that have been watching mine. So, there's a couple of cool projects out there that I follow up on all the time, and then we're going to get into the last one that has to do with the Tesla coil and some of the stuff that I did. So, let's go ahead and take a look first at the first one we're going to look at, and I will share it right here. And hopefully, if I mispronounce the name, I'm sorry, I didn't mean to. So, Johann Reeder, I would imagine that's French, but I'm not sure. And this is what we're going to take a look at. It says the no free energy coil. So he's just outright telling you that it's not free energy, but he's going to study the coil, which is totally awesome with me. I can go with that. So let's just take a look at it. So let me see if I can't make that any bigger. So basically what we got here, guys, is he has a coil, and we can see he's just running into one transistor right there. Could be a MOSFET. I'm not sure. Let me see the number. TIP, that's probably a transistor. So I want to get a good picture of the coil. Here we go. So basically what we have is a field within a field within a field. So this is why I think it's so interesting. You have magnets, and I believe they're directed so north out on the bottom. So it would go like this, so they're not opposing. So I don't think he's pulling a lot of energy in there. Then he has the coil itself that's on the inside, and then the actual coils on the outside are individual strands of wire. What I do like about this is if you pulse the inside, it'll pick up the energy on the outside. If you pulse the outside, it'll pick up the energy on the inside. And we're not talking a whole lot of voltage here. But the one thing that is you've got three magnetic fields possibly here. So when you shorten it, and that's what he's going to do in his next video, he's going to shorten it, change the magnetic direction. Now you're going to start pinching fields. That's when you start pulling a lot of energy, because the Tesla field you're looking for in any kind of magnetic area is how much you pinch this field. So the more pincher you can put on it, the more that you can produce out of anything. So let's go ahead and let's take a look a little more on his channel here. So in this one, we could see that he changed the configuration of the coil. It got shorter. So as we see it got shorter in there, now he has some compression going on. He has the top and bottom magnet, which just look like microwave magnets. Then he has the coil wrapped tighter around the outside, which is a good move right there. So now he's really going to get some compression out of this. The last one was loosely on there. But then the center winding is a lot more. Now, I can't tell the direction of which way everything's going right now. I can tell you he's probably improved the output of this coil just based on the way it looks right here. So, yeah, he's got more on the outer coil as well. Absolutely. So thank you for that, Richard. So let's just take a look, guys. What we're looking at is three magnetic fields, the two magnets. Obviously, I guess you could technically say four, but I'm going to say three. The magnets together is creating a field inside. So it's going to bring a heavy Tesla number on the actual coil in the center. So you should be able to get a value out of it. Now, which way is it wound? I don't know, but you could definitely tell you're going to get rotation out of it. So even if he creates rotation out of it, even he starts it, if he starts the winding on the inside and puts power to the inside, it'll push out, but then the magnets itself could counteract that. So you have to watch that. But if he has them in the correct direction, that means that the wiring on the outside actually picks up more energy. And based on the way it's winding on the outside, he's going to get rotation on that. So it's not going to be stagnant in one area, which is going to be good because it'll draw down the heat on it. So he's going to get more volts out of it. So really interesting project here, guys. I'll put his link in the channel. Excuse me. In the chat, so you guys have it. Let's take a look and see what else he's got going on here. So he's got some high voltage, and as you guys know anything about me, you know I love high voltage. So we basically have a flyback here. Man, that's a lot of capacitance you got going on there. So he has a light going. It's flipping out his camera. That thing is on. Yeah, you got to get the zoom working on that camera and pull it back. I can see the light lighting. So what do we got here? It looks like a ZVS driver that he made. Definitely getting the H wave, the energy spike in there. Okay, I don't know why it's freaking out on him. He probably has that whole thing too close to his high voltage. That's not exactly what you want. So I will do update on the gravity flyer at a little later when I get into the other video, because I've been trying to explain something and I don't think people are getting it. So I'll have to do that. But yeah, look at all that capacitance, man. I don't know that you would need all that to light that light bulb. You could probably light it just from the flyback. But you're getting mostly volts out of it, not amps. So let's take a look. So that's an interesting one. Let's go see what else he's got on here. Oh, hold on. Go back. Oh, he's got a taser out. That's pretty cool. And he's lighting up the neon bulb. That's really cool. I could put my Tesla coil probably next to that and light that thing. Let's see what else he's got. I think that's pretty cool, though, man. He's got a lot of cool experiments going on. He just started his channel, so I'm going to go ahead and share that, guys, so you guys can take a look at it. There you go, right there. There's his channel. I put it in the description. What's up, Mike? And then we're going to take a look at another one real quick. Peter Hall Effect 2.0 is what we got going on here. I like this guy's channel. He's got some cool things going on. He's got his Jewel Thief circuit on here. As you can see, pretty much what Gerald's running, close to it, and Gerald's is modified a little bit more. I see a full bridge rectifier there on the right, the MOSFET on the left. We see the capacitor, and we also see the coil in there. Obviously, it's just a standardized coil, but he's working it. You can also see he's got a wrapped coil sitting over to the left. So he's just going to check the amount that goes in the capacitor here. So let's see what he's got going on. That's the one in from the full bridge rectifier there. So he's got a DC power source, so he must be rectifying back to AC in this whole process. As he turns it up, it's going to go ahead and charge the capacitor. So not bad. All right, let's see what else he's got going on here. Ooh, we got a little bit of a pulse motor going on here. Check that out. Yeah, that's pretty interesting, man. He's got the 4-bridge rectifier on it. Apparently, he wants to get it converted right away. That's probably a pretty good plan, to be honest with you. So he just put a coil inside your main pulse coil there. And I don't know if it's a starter coil or what he's got going on there, but let's go ahead and turn the volume on and we'll check it out.
Through radiation. Power. That's just me touching this power cord right here to it. It'll make the LED flash. And what that is the magnetic field in this coil collapsing. So when the power runs through it and it has nowhere to go, it escapes through the air, through radiation. And it gets inducted, or this works like a magnet, sucking the power from this coil into the blue coil, which lights the light. So this does not slow down my rotor because I'm not using the magnetic field to generate the power of this LED. I'm using the power from the collapsing field of the Bendini coil right here, the bifiller. The magnet isn't doing so much of the generating of electricity as just the induction, the magnetic field collapsing. I'm going to show you that right now. Let me start this up. You can see the difference. I'm going to pull this light out of here. See how close I have to get it to go on to the magnetic field. But all I got to do is bring it. So when I bring it close to this coil, it turns the LED on. I can get this to light up nice and bright. And it does speed up the rotor. Doesn't slow it down at all. Okay, but this I want to show you. The Ronin coil, it doesn't slow it down either. In fact, I'm going to put it on alternating current and just show you. Listen to the rotor. Check that out. I get 4 volts back. 5 volts of alternating current. And it doesn't slow down the rotor either. 4 volts. And I had LEDs hooked up to it, but it would burn them right out. So this coil is a good generator coil. I made this one out of aluminum, and I overwound it. It's a lot more turns on it than the normal Rodin coil. But just to show you that it doesn't slow things down either. It doesn't speed it up though. This here, you can actually hear the speed up effect. Anyways, I thought you might enjoy that.
Man, playing with the little fire there, getting it real close, man. That's really cool. I like the effects that's going on there, showing how it produces power in it. So that one's cool, man. And then he just got a 3D printer. So he was over there working it, building some how do I say it? Just the standard stuff.
Make it, do it, makes us.
So he's getting in the game, guys. So I really do appreciate this. I'll go ahead and put the link in the description for his channel, guys, if you want to check him out. It sounds like he's going somewhere good with it, so I really do appreciate that. And there you go. His link is in the description. Okay. We are going to take a look at one more, and then I'll get to the Gravity Flyer update that people probably want.
Yeah, just in your.
All right, guys, we're going to check this out now. Just so everybody knows what it is, that right there is a ZVS. He's connecting it to a number one coil, basically build a Tesla coil out of it. And he's studying some of the features that we did with Sean and myself on the ZVS circuit and putting it into a Tesla coil and see what he can get out of it. So let's go ahead and play it and watch.
Okay, just in reply, a quick one. I ain't got a lot of time this weekend, but we still have the input 18 volts battery. Again, ZVS to a L1 to L2, which is inside, and then instead of the top going to a top load, I've got it going through the coil and then back to a ground. Instead of a spark, I've connected to two ends of the L2 to a transformer, just to see what the output would be in voltage DC, as we have 18 volts input. And so I have a multimeter here, which is on the volts battery tester, shall I say, this side. So as these illuminate, I don't know if you can see that, we have 1, 2, 3, 4, that's 50 volts DC. Okay, 18 volts in, 50 volts DC out, coming this way. Okay, there's nothing else. We have it connected through the earth, of course, one side of the transformer. Excuse me. So 18 volts in, you can see 50 volts on the output. A lot more work to do here. Could be a way of maybe looping this back. I need to find a smaller transformer that will go in line with the ZVS driver, but in theory we should be able to split this and have something running off it as well as coming back here. A little bit confused here. We may need capacitor. Interesting, because definitely a lot of power here. Just so you can see everything.
Mike, what's going on?
Not too much. How are you?
Oh, pretty good.
That's
Did you
good.
see that last video?
Yeah, I did. Yeah.
So
Yeah, cool.
Yeah, he's pulling more energy out of it.
Yeah. Well, I've done that experiment too. Actually, taken the metal core out and then put another coil on the inside, preferably higher gauge, like say 28 or higher, and wrap it into a coil, stick it inside, and yeah, you'll get voltage out enough to light a light.
Oh, you're talking about the pulse motor?
Oh, yeah, the pulse motor. Yeah.
Yeah, that was awesome, man.
Yeah.
kind of one of those interesting things. I don't build pulse motors, so I always like to watch them and just see what's
Right.
going on.
See, with a pulse motor, a lot of people don't understand that inductance can either be your friend or it could be your enemy. So there's novel ways on how to litigate that problem. Where in my Renegade, what I use is piezo transducers. So I'm taking that frequency, I'm buzzing it at a very, very high frequency. What happens is you'll still get the power output, actually more, and it reduces the inductance of the coil. So therefore, you're drawing less current off your power source. That's one of the keys to the Renegade.
So it basically pulls it out faster than it can, not create it, but faster than it can produce the heat.
Correct. Yes.
That's awesome.
Yeah. And a lot. So basically, inductance can be your friend or your enemy. It's how you use that inductance to your advantage. In the Renegade device, I've figured out a way how to control the inductance in the coil with a steel core and get the performance I need and get very little current coming out of my power source.
Nice.
So that will be in next week's my presentation. So that's just a little piece of it.
Man, I'm really looking forward to that presentation, man.
Mm.
I wanted to build a pulse motor. I just didn't want to do it until I was ready. You know what I mean?
It is so easy. It is ridiculously easy. I got a couple of pictures to show you the basic setup of a pulse motor. And then right from that starting point, you can go crazy with that circuit. But until you understand the basic circuit, which is ridiculously easy, and after you get that, then you can start tweaking it, changing stuff, add a different switch. Instead of using a reed switch, switch to, say, like a proximity sensor like I use from a 3D printer as my trigger. So yeah, so stuff like that. So I'll show pictures of the basic pulse motor on how to wire it up. As soon as you get that and understand that concept, sky's the limit. You can change it in many ways.
Oh, that's good. Because I got plenty of magnets, I got plenty of wire, and then I got my 3D printer. So I got plenty of transistors and MOSFETs and all that stuff. So
well, I'll even show everybody how to build a pulse motor with everything you can get from like Auto Mart or Home Depot and stuff like that. That you don't need a transistor to build a pulse motor, and still get amazing effects.
So you can bypass that whole thing, huh?
Yep.
Oh, well, now I'm really going to be excited because I love it when you get to something that's like a contactor or anything that gets rid of that transistor.
That's right.
Yeah.
So I was able to modify an automotive relay switch, a 12-volt relay switch that could handle, 40, 50 amps. Now I also learned how to tweak it to actually make it pulse faster. So instead of using a MOSFET, I'm using basically a relay for automotive. Automotive relay costs $7 at Canadian Tire. And I'll use that over any SSR, any MOSFET, anything. I'll use that over anything.
So is it like a starter relay when you basically it's like a 10-volt trigger and then you can run as much voltage through it as you want and it'll just hit it?
Yeah, because I'm drawing such little current off it. Say it had a 10 amp rating. Well, there's no way in hell you're going to be drawing 10 amps through that switch. So it's not going to do any thermal damage to the switch.
And does it move fast enough for everything?
Yeah, because I was able to overclock it so fast that it doesn't allow it to get to a dangerous point of pulling current. It's in the milliwatts.
I like those things because one side of them is a high level, so you can put a lot of voltage through them and a lot of current. The other side is a low level, so switching is really fast because it's very, very low power that goes into it. It's like a high-low.
Yeah, you could put as low as I think I've ran it on 9 volts before just to trigger it. So, and it doesn't take much current to run it. So, It's an ideal switch. It's robust. It's readily available. You can pick it up at Princess Auto, Automart, UAP, whatever. You know, they're cheap. They're like $7 at Canadian Tire. So,
Hmm.
you know, it's that's
I
what I
have
love
one for
about
my boat, but I had an
Yep.
extra one for my boat, and I used it in a couple projects. I'm gonna have to dig that thing out now.
Yep. The only thing electronic I use in my pulse motors is the 3D printer proximity sensor. And that's also very easy to hook up to, and they don't draw much current.
Oh,
So,
okay.
and they're very fast triggering, extremely fast triggering. So you don't have to worry about getting the speed of a MOSFET because the way I've configured it, you'll get all of that. So,
Okay.
yep,
Very
very
nice.
yep. So I'm just waiting for my wife to come back with the car. I have to do some errands, but I was doing laundry early this morning, so I got that out of the way. And then as soon as I get my errands done, I'll be on the bench working on my projects. Oh, update on my cell. The cell bank I built in August.
The smaller one.
Yeah, the small one, that little one,
Okay.
still working. It's been operating since August, still working.
Nice.
Yeah, it's running a 12 volt, 300 milliamp tracer light. So it takes about 300 milliamps to make that light go because it's rated at 12 volts. But the cell bank's only about 5.5 volts. So it has to pull 300 milliamps to make that run. So it's been doing it since August. It's still running strong.
Nice. That's very cool, man.
Yeah.
When are you going to start load testing those things? Do you have something in mind?
Well, I've been building the 12-inch version of the cell banks. I've got 4 completed now. I'm hoping to get a few done today. We're still kind of finalizing what we're putting on the inside. I did a lot of research on the sacrificial cathode, how to cut it, how to lay it out inside the cell properly to get maximum voltage and current out of it. So that's pretty much I've been doing all week, is researching just that one thing. And I've been using ChatGPT for answers. And every time I have the conversation with it, it seems to know what I'm already talking about. And it's getting more elaborate, more detailed on the answers, which is I'm starting to find pretty cool. It like already knows who I am.
Well, AI works in patterns. So every time that you keep going for the same thing over and over and over again, it pulls more information for that. So it's going to bounce back more to you.
Yeah, and it's like the answers are like 6 pages long. Like it's giving me some pretty elaborate information that's like incredibly helpful. So yeah, like how I look at the sacrificial cathode is like totally different now compared to what I was doing before. And yeah, it should optimize performance and longevity. So
very cool.
That's the key. Yeah, it's a nice day here in Toronto. It's a little cool. It went down to 4 degrees Celsius last night. I had frost on the windows this morning on the car. So yeah, it's starting to cool down. Yeah, I'm in a winter jacket already.
Yeah. Well, just to give you an idea, I'm in California. I was out in my shorts this morning walking the track. So it's
that's the price you pay when you live in the Great White North.
Yeah.
It's windy too. Leaves are falling now. The colors are nice. All the colors of the trees are changing now. I don't know if you can see that.
Yeah.
All going orange and yellows. It's really nice. Did a nice little trip up the escarpment last weekend, and the colors were just stunning.
Nice.
Yeah.
Yeah, we still got a little while before we start to get to that.
Mm-hmm.
So.
Yeah, your Thanksgiving's coming up soon, isn't it?
Yeah.
Yeah.
So November 25th, I think it is.
Oh, you guys have it pretty late.
Yeah.
And then right after that, it's Christmas. Holy cow. That's like less like a month apart.
Yeah. Just one right after another.
Yeah. Yeah. My daughter's getting all geared up for Halloween this week. So got to do the Halloween tradition, right?
Yeah. Well, not anymore, man. My kids are all older. Sometimes they dress up, but I don't partake in it anymore.
Yeah. I think my daughter doesn't want me around for this one. She's at that age where she doesn't, she's, going to be 13 next year. So she's at that age where like parents are ugly and, don't touch me and,
Yeah, no, I understand that one.
total antisocial, right?
They always drag me along at that age just to carry the candy and stuff.
Yeah.
But then once that gets old and they're out with their friends, you're done.
That's it. Yeah. She's at that age now. So, yeah, she'll probably be out with her friends that night. So it'll be easier for us.
Yeah.
So next week, just for everybody, I will be doing a show Friday night at 9:00 Eastern. I thought I was going on afternoons this week, but we had a meeting last week and they kind of changed that. So I got one more week, and then after that, we're supposed to go on afternoons for a couple weeks. So it all depends on our workload at work, right? Right now, we're kind of busy right now with some projects and stuff. I've been cutting a lot of ballistic materials. It's fiberglass. It's about half-inch thick. And I'm cutting the stuff on the water jet, and it uses water, so it's got a tank below it. So all the resin, and fiberglass, how toxic that smell is, it gets in the water. So now the whole water jet tank smells like resin.
Oh.
So it's like, oh my God, like by the end of the shift there on Friday, it was like, oh my God, I'm getting like high.
You're going to have to filter that out as soon as you're done with your job.
Oh, that's the first thing I'm doing Monday morning when I get back in is I'm going to start draining the tank a bit and get some fresh water in there because when that resin gets in there, the smell does not go away.
No, it clogs it up, doesn't it?
Well, yeah, that too. Yeah, there's a bit of coagulation in there, but it's the smell. It's the smell that's brutal. And it'll give you a headache. But that project's pretty much done, thank God.
Yeah.
But yeah, they seem to be a regular customer for us. They make, I think they're making desks for say jewelry places. So, they have a bulletproof casing for their stuff. Yeah. So, and it's heavy too. That fiberglass, I was really shocked that, it's a half-inch thick, but man, is it heavy. It is heavy.
Yeah, sounds like it. Well, if it's going to be bulletproof, it better be.
Mm-hmm. Yeah, exactly. Yeah, extremely heavy. So yeah, that's I'll be working on the projects this afternoon. I think I might even try to get a video out. Like I've been more focused on the live shows, right?
Yeah.
My stuff, and I've been really consumed with the power cell project. So I haven't really made too many videos. But the thing is, I've got over 460 videos on my YouTube channel. There's lots of stuff there. And you can kind of see where I started, being kind of green and not really knowing too much, to getting more intelligent as the time goes on, right? I'm learning stuff along the way.
Absolutely.
So, yeah, like 460 videos. I got well over 100 live shows. My community section's really big too. There's a lot of great links to really important videos and stuff like that. So my channel's really grown as far as content. Like there's a lot of content on my YouTube channel.
I'm going to put it. Sorry, I'm going to put it in the comments right now. Your link for your channel.
Hey, thank you. Yeah. So, yeah, I try to talk to give out a lot of answers, but now it's to the point where I say refer to the videos because all the answers are in the videos. You just have to watch the videos, right? you know, like certain things I'll answer because maybe I didn't touch on it in a video or whatever, or it's something totally different than what I've been doing. That's fine. But I always try to refer people to the videos and watch and see what I'm doing, right?
Well, have
So
you ever looked at it like maybe throw 3 of the videos together or 4 and do a compilation and then stop it and give little pointers that you didn't give before?
Yeah, I was thinking about doing that too. I've actually the last week too. I've been downloading a lot of the videos I posted on YouTube, so I got a hard copy of it, and I plan to start uploading a lot of these videos to Rumble because I want to get my footprint on Rumble as well. So I got to start doing that, and that's a lot of work. A lot of work.
Yep. Oh, I know. I've done it.
So yeah, I have so much things to do, Nathan. It's like I wish I could add another 10 hours to the day just to get everything done, but it's not possible.
Well, yeah, I'm there with you. I got projects of my own, man, and they keep piling up. And then, like, as soon as you get through one, you're like, I have 5 more because of where the directions led with that one. That you got to just limit it, I guess.
Yeah.
I wish I had somebody here with me to do it with me and make it a lot easier. We can go in different directions, you know?
Right. That's kind of what happened with me and the Renegade. I was working on that for well over 2 years. And then in the background, I was working on the power cells. So now I kind of flipped the thing to working on the power cells more than the pulse motor, because sometimes you have to step away from a project a little bit to get new ideas.
Yeah.
And refresh your mind, you know? So that's it too. So that's why I've been really focused on the power cell technology, because I see where this is leading. So yeah, time will tell, right?
Yeah, it'd be interesting to see you take your your cell that you're building and maybe make a startup for your motor. You know what I mean? To set the trigger for it to get it to turn on, or I don't know how it all works, but it'd be neat to see them together.
Yeah, the two are going together. That is the reason why I'm working on these cells, because exactly what you just said. The cells are going to run the pulse motor, because I know the pulse motor is super hyper efficient. So now if you got a battery bank that doesn't run out of power, well, you could call it what you want.
Yeah, I get it.
Right?
I like it. I like the whole idea of it.
And, the amount of reactive power that this thing's generating for how much I'm putting in, it was a no-brainer to develop the cell to go with the Renegade. It was a no-brainer. So, battery storage, okay, that's a different thing. You always need battery storage, but that's not what I want to make. I want to make, basically a solid-state generator. And that's what the power cells are. Now I know why, the government, they have these nuclear batteries that work really, really good. Mm-hmm. But the only fallback is they're radioactive. And that's why they'll never go into, regular circulation, I've seen guys make small scale ones, buying those little keychains with the tritium.
Yeah.
They'll wrap a whole bunch of those things together, put it in an inductor, and then put it through a Joule thief and create power with it. And create their own kind of like nuclear battery, right?
Yeah. There was a comment, Bismuth. We're going to have to start using that a little bit. I kind of want to see what it's going to do.
Yeah, I haven't really dabbled with the bismuth.
It has a high reactance. When it gets to a certain level, it just skyrockets. So it would be.
Yeah, I have to see where it is on the periodic table, because right now I'm working with group 1 and group 2 reactive metals.
Okay.
So I got to see where the bismuth lands. Offhand, I don't know.
Well, I think we all are going to end up on that sooner than later. I can tell you that.
Well, I think where the battery technology hasn't really gone to is, okay, they're always in the quest to make a better battery. Okay, granted. Mm-hmm. But the sacrificial cathode in a battery is probably even more important, because if you can control or negate the decay of the sacrificial cathode, well, the cell is going to stay alive for way longer than expected, right? So I'm sure people are working on it, in big laboratories, but I'm sure they've come up with some solutions, but why isn't it out in industry? Why hasn't it hit the regular market?
Yeah.
It boils down to the dollar. They want to make sales. They want to sell batteries.
Yeah. Well, it's usually what it is. Either that or they haven't pushed it to the point where it's small enough and getting enough power for them in order to make it work out. You know what I mean? It always ruins itself before it gets that level, and everybody's just on this thing that's way too high of a power. Like, let me put it this way. If I took your blender and I ripped out the AC parts of it and ran it on DC, quarter of the power, maybe less, is all it would take. They're trying to get it too high just so they can get to the voltage that's going to drop the voltage anyway in order to run the motor that's in it. So maybe we should start looking at that too and kind of rethink how we do this.
Yeah, definitely.
So,
Yep.
Yeah, it would be a lot easier. I can tell you this: most household appliances are very low voltage DC. Even your air conditioner, by the way, is a brushless DC motor. They converted over from 220 volts to a brushless DC, which, if we would have just ran the brushless DC from the beginning, we probably wouldn't need as much power.
Exactly. They just do that so you're feeding off the regular power grid. They want to charge kilowatt hours, right?
Yeah. Well, it would have been a lot easier if they would have just put AC in, converted it at the box, and then we get DC in the house. That would bring down the amount of usage by a lot.
Oh, massive factor. Massive. Like the street lights outside, they run on, probably 120 volts, 60 hertz. If you change the frequency of what the lights work at, change it to 120 or even 220 hertz. Now you got a huge energy savings on that.
Yeah.
Just by running the lights at a higher frequency. So therefore, less strain on the power grid. Like they can't be this stupid. Right?
Nope. Hey, their bank account says that they're not. They knew exactly what they were doing.
Yeah, it's about making money, and that's what's holding us back as a society to go forward and make things the right way.
Yeah. Right?
I
agree with that.
Yeah, the same like your TV, and that's another one. It runs on DC.
Yeah. And very little DC, by the way.
Exactly. It can run off a 12-volt battery. So they have an inverter built in it, so you have to feed off the grid, and then the inverter just drops it down to 12 volts, and that runs your TV. It's ridiculous.
Yeah, that's absolutely a fact. So, yeah, my father-in-law would take a 12-volt battery, his car battery, and just run, with the inverter back to the TV and be able to run that stuff like all the time.
Oh, yeah. Yep. You could even bypass the inverter that's built in the TV itself in the power supply and just hook it directly up to a 12-volt battery and it'll run.
Yeah.
Yep.
The things we learn when we actually try, you know what I mean? The things they don't want us to see all the time.
Yeah, because you'll open up the back of the TV and anybody who knows electronics is going to look at it and go, this freaking thing runs on 12 volts. Why do we got 120 going in it?
Yeah.
Right? It's just, yeah.
Well, yeah. Well, think about it. If you took just your shop area that you work in for your project and you converted to DC from, say, your Renegade device, you would just straight up drop all that power source that you're using for everything in your garage to an extremely low level where you can loop it easily.
Yep. Yeah, Eric Dollard used to talk about that with the power grid. The power grid system was so huge. It had so much energy within the system itself. They had generators running off the power that was already on the grid.
Yeah. That I can believe that. Well, because the power is not going anywhere until it's being used. And even at that, they're pulling in the negative from the ground.
That's right. It's a loop system. It's a closed system, right? It's just looping it right back to the start. So, like, if you're not using all the power in your house, it goes right back to the power company. It's looped right back.
That's right.
Eric Dollar had some good videos on that. He was talking about the power grid and how it works and how we're getting kind of hosed.
Yeah. And not only that, it's kind of dangerous, though, too. You know what I mean?
Yeah. Yeah. How they were hooking the Y configuration and that. You know, like, and the other thing, too, is the reactive power. They don't consider it real power, but say, like, big plants that have heavy machinery, they depend on that reactive power to get those machines powered.
Yeah.
So what does the power company do? They charge them a premium price for reactive power.
That's ridiculous.
So they're getting screwed again.
Yeah. Oh, I live in California. We're all about screwing people over for energy here. They do brownouts and things like that. And, you know, they just have to fix it. And they always say, well, we don't have the right grid or we need to improve the grid. But then when they get their money, they don't improve the grid. They just spend it on other stuff and pay their executives a ton of money. So I'd love it for it to go back to the grid. I'd feel better about paying my bill. At least then I wouldn't have 110 degree weather outside, my air conditioner not working.
Yep. Yeah. But, from what I know now, the way things are, how the power grid works and how they're screwing us for money left, right, and center, and how inefficient and the redundancy of the system. I'm totally for a decentralized power system. I'm 100% for it.
I don't know about decentralized. I don't get into that end of it.
Yeah,
I'd rather they convert it to DC to the house.
Yeah, that would make a house way more efficient by far. That's a start.
And it'd be safer for everybody.
It is. Yep. Exactly. Yep.
So anyway, I don't want to rail on the power companies or anything too much. You know what I mean? Well, they do their thing, and I don't want them in my garage at all.
Yeah, exactly. We won't say anything.
Yeah, we're just do our own thing. So
now with the technology maturing and people like yourself and myself doing what we're doing, we have options now, right? So we can change stuff in the house, like, instead of running it off the grid, you can put a switch on the main power box coming into the house. And then during peak hours where the energy costs are more expensive than non-peak hours, you could go to flip the switch on your box, turn your power system on and run your house during the peak hours. So now you're saving kilowatt hours, and they'll take, maybe 30-40% off your electrical bill right there.
Yeah, but then let me just tell you about the government here in California. They will find out that you're doing some kind of system besides energy savings with the battery, and then they'll charge you for it. So, and then they'll charge you fees on top of that. And then they'll probably put you in jail because they think you're stealing. So they got their grip on everything. So I would just say it is, we can turn on our battery bank from our solar panels that we have, and then you can use all that energy during the peak hours, which is perfectly legal.
But still, the way I see it, they're energy Nazis. And I'm not afraid to say that, too. That's what exactly.
Well, I know you're not. I'm just trying to tap dance around the issue a little bit.
Yeah. But, it's kind of like that here, too. Like a lot of people have solar panels on their houses. There's a condo right in front of me. The whole top of the condo is all covered with solar panels. But the way they've changed the laws and Trudeau and what he's done, there's no incentive to put solar panels on your house anymore because you're not getting any special breaks or rebates. Even for cars now, apparently some of those rebates are starting to disappear.
Yeah. Well, also, when they came out and quoted your house, like at least the experience I had, I got solar panels. They don't quote enough solar panels so that you don't have enough to get to a 0 point most of the time. It would be nice, but they don't do it. And you don't actually get to use the solar panels to put energy into a battery bank. It goes back to the grid. So
Yeah, see.
then they confuse the billing on it. So it looks like gibberish, which it probably is. And they don't change your meter outside. So how are they even accounting for it? So it's not like it runs backward at any time. I've never seen it unless somebody illegally did it. You know what I mean? But I've never had a time where everything's off in my house and my power meter goes the other way. It just doesn't happen.
Yeah. And I think they want that. Yeah. Yeah, it's unfortunate. That's the way the system is. The problem is when the government runs the system, they call the shots. So irregardless, it's like the system is rigged against you,
Yeah.
So
yeah. Anyway, all right.
I got
looking at more projects.
Yeah, I got a jet here. I got some errands I got to do. So everybody have a great day, and we'll see everybody on Friday night.
Right on, man. We'll also see you next week on Sunday so we can do your presentation.
Yep, sounds good.
Right
Take
on,
care.
Mike. Have a great day.
You too. Bye.
All right, guys, let's get back to this. So I want to go back and touch on a few points here. So what we have going on in this video, just so you know, we have this thing running. It's basically running a Tesla coil. He put the wire down the center of it, and he's getting more power out. So we're going to go ahead and play this a little bit again because I want you to see it again. Guys, this right here is important. You want to know about the gravity flyer? This is something you better start understanding because you're going to pull power out of the center of this thing, and it's going to be more than what you're putting in. So let's go ahead and play it one more time so everybody who hasn't seen it yet gets to see it.
To L2, which is inside. And then instead of the top going to a top load, I've got it going through the coil and then back to a ground. Instead of a SPAC, I've connected to two ends of the L2 to a transformer, just to see what the output would be in voltage DC, as we have 18 volts input. And so I have a multimeter here, which is on the volts battery tester, should I say, this side. So as these illuminate, I don't know if you can see that, we have 1, 2, 3, 4. That's 50 volts DC. Okay, 18 volts in, 50 volts DC out, coming this way. Okay, there's nothing else. We have it connected through the earth, of course, one side of the transformer. Excuse me. So 18 volts in, you can see 50 volts on the output. A lot more work to do here. Could be a way of maybe looping this back. I need to find a smaller transformer that will go in line with the Z.
Okay, so let's just understand this. He said he had his number 2 coil connected to the wire that goes through the center of his Tesla coil. So he's trying to trick the game here. Just understand this. Put the wire in there without connection it to the number 2 coil at all. Then you connect your Tesla coil number 2 wire, not the output, but the bottom of it, to the ground. Now you'll start seeing what I'm seeing in my gravity flyer. People always want an update on it, and they want to know what you need to learn. Well, you got to learn that Tesla coil in a different way. And I continue to say it, and people don't understand it because they still think you're connecting the wire to the output of the secondary, of the Tesla coil. And I'm just not doing it. It's not the right energy. It's not what I want. I want to be able to use the ground as a capacitor. That's the important thing here. Double grounding, ground as a capacitor, and that makes the biggest difference in the world. So, yep. Yeah, it's really important. So we'll go ahead and we'll take a look at one of the other times he ran it here, and then we'll go on to what I was doing so that we can now understand what we're looking for. So we see some ways to do it, and we're amplifying energy. That's still good. I'm happy with that. Any way that you can amplify your energy, you're going to make my day. So what I didn't see in there was the amps and volts readout of it, or if it was changing the energy. So we'll have to wait and see that, and knowing him, he'll get it done. So let's see what else he had going on here. All right, where is it? I just saw it a couple days ago. Oh, by the way, this guy does absolutely amazing chronomotor. Let me see.
And from his drawings, it looked like he split L1, but I'm now thinking that it's split the L2. And this is what I'm going to show you. 16 volt DC, ZVS driver, L1. Inside the tube, I have a thinly coiled wire, one end going out this end, and the other end should normally go out this end, as in previous videos. But what I've done, I've pulled it back through the tube inside of itself. And one end is with a fluorescent tube. The other end, I will put on it afterwards, but we have it earthed. Now that coupled with the earth makes a significant difference in the output. On top of that, I have a bifilar coil. Again, this is the beginning phase, and this is a bulb from a microwave oven transformer circuit. So I presume it's AC, but I'll try and do this and show you the result with one hand. Okay, so basically this is what we've got. There's the bulb from the microwave oven transformer. I've got the earth connected to the other side, which is going through the tube. Okay, you can see the fluorescent light there, and that's fully lit. That's more than the value of the bulb. So, and this was actually teetering because, again, nothing's connected. It's just put together. So the interesting thing, what I wanted you to look at, was that this cable, this white cable, which is connected to the first winding underneath this bifilar winding, is what was interesting. And that I think that's something to play with, because there's a lot of power in the center here when you're making your Tesla coils. There's something that we missed that is in this center part of the coil that we could be utilizing, and I think that's what gives it the extra output. But stay posted.
Okay. Now you guys understand a little bit more, right? But there's a whole nother level to this. He's taking his secondary. Now he's running the number one coil in the center instead of on one side or the other, right? So he's able to do it based on one could be a ground on either side. It's an interesting way to look at it, I guess. Not exactly the way I do it, but that's okay. I like the different experiment. So then he pulls it right back through so that he can multiply it. why is it gaining more energy? It's a real simple answer. You have a coil of wire, and the coil of wire creates a magnetic pinch in the center. That's as simple an answer as I can give you for it. The magnetization is higher in the center based on the way a magnet works. So it's a very thin gauge wire on the outside of most Tesla coils. It looks a little thicker, but it's the same answer. You're going to pinch the energy in the inside and you're going to gain more energy out of it, right? Because essentially, he's not only pick up the energy based on how the Tesla coil works, but now he's multiplying that energy based on the amount of magnetic force that's being pushed upon the wire. What is the one thing that you need to look at in that circuit, though? It's where that ground comes in. People don't think there's energy in the ground, but I can guarantee you there's energy in the ground. The ground actually works as a capacitor. So let's go ahead and look at this. I'm going to go ahead and show you what I do. It's going to be a bit different, guys, but I'm going to have some of the same principles going on here, but it's a totally different way to look at it, I guess. So let's pull it up. Find it right here. I have a cool experiment going on right now. This is my Tesla coil. It's not grounded, but I have my Slayer-Steiner circuit connected to it. Power supply. Got a light on in the background. I have my rodent coil right here. Now, there's nothing on it, nothing connected to it, other than a simple wire. So let's look at the connection. You can see the light bulb above it. I'm just connected to one wire of the rodent coil. It goes onto the white wire. Sorry, this thing. I have a cool experiment. Let me just bring it to the right point. As I put the wire down there. You can see right there, it changes that. That's totally awesome in itself. But this is... Okay, let's stop right there for 1 second. What did I just do to that coil? Basically, what I did was I just added the capacitance of the other coil. That's it. What it does is it lowers the resonance of the primary coil. The Tesla coil resonance changes. So what happens is it's producing more energy out of it. I have just changed that circuit. You may not look like much, but the result when you start changing more parts of the circuit, it's really going to become apparent. I'm playing on anomalies here. I'm finding them. And as I find them, I amplify them. That's going to become important. You don't just put things down the center without knowing what you're doing. It changes the value of things. On my oscilloscope, what it does is it will drop that frequency. So if I'm running at 340 kilohertz, as soon as I put that wire down there, regardless of how thin that wire is, whatever the amount of wire is attached to the rodent coil, it'll start to drop it. So I could be resonating at 1,000 kilohertz by the time I was done putting the wire in there. That's the understanding of it. The more you're out of resonance when you're on a Slayer-Steiner, the further it'll drop. So I'm right there at perfect resonance. Exact spot's going to resonate at, which means my kilohertz will only drop, maybe 50 kilohertz. That's it. But if I set my coil where I am out of resonance, I put the bottom at, say, 600 kilohertz, and then I put the number 2 of the coil at 320 kilohertz, where it likes to be. What happens when I put that wire down the throat now? Now I'm going to change that Tesla coil, and I'm going to drop the kilohertz down to hertz. That's how it happens. That's how it works. So it's an interesting fact. Again, that's two interesting facts we just learned right there. So let's go on and see the experiment. Start to dim until it goes out. The wire's in. We now have the coil turning it on. Pull the wire out. You can see it dims a little bit, but it'll start to dim until it goes out. That's cool, isn't it? Let's do it again. We'll put the wire down the Tesla coil. Lights up pretty bright, guys. There is no direct connection to this Tesla coil. The wire's just down the center of it. So, there you go. You can see the light. There's the wire. I just got it hanging down the center. That's it. Bright as can be. That's pretty cool, isn't it? So, let me give it a little more juice. Let me see what I can get out of this. So, 24 volts now. It still lights up. Matter of fact, it's probably lighting up worse. Oh, there we go. Now it's doing good. But we still haven't hit the other ones behind it. There's light bulbs. They haven't lit up. Let's take a look at this. What happens to this right here? Sorry, I'm getting over the wire right there. Now you can see it really cooking, right? Watch. Hit the side. You got it right there. Is that not cool or what? All right. I know it's just me goofing around playing with this. Let's give it a little more voltage. Okay, real quick. I just want to tell you what I was doing right there. When you put the wire down, it has sharp edges. And what they do is they break out in voltage. So as it's pulling in the voltage to the wire, again, it's pulling it in. It's not breaking it out. It's pulling it in. As it's pulling in there, it'll start to create heat. You don't want the heat. So every time that I move that wire up and down like this, right, I'm playing with the heat that I'm putting in my rodent coil. That's what I'm doing right there. I'm playing with the heat. I'm playing with the inductance in it. And I'm changing the value of exactly what's going on in that circuit. So as I put it further down, it goes all the way down. Then it'll change it again. That's the cool part of what's going on here. I run it hot right there. You could see it was hot. You could see the sparks right there. You could see it pulling the energy in. Now, I'm going to go ahead and pull that wire out and show you that it'll still run. Man, here I am looking at this and I'm thinking you guys are watching with me. I'm sorry. That's my fault. Okay, now I know it's working. All right. No, light's the same. Here is what we're getting when we put it down the Tesla coil now. We're starting to get a little more breakout. Now I'd say breakout, but it's actually pulling it in. You could see it right there. Again, that is not connected to anything. It's just a wire inside my Tesla coil. And we're getting arcing. We're getting a secondary right there. God, I torture this stuff. Okay. Our light is still on, by the way. There's our wire. There's the end of it. And our light bulb is still on. Now, just so we understand that, here he is. The wire is out. The light's still on. So what am I doing? Well, I'm playing with the heat in the coil, number one. But the second thing is I'm playing in the resonance value of the rodent coil itself. I'm causing it to resonate to each other, to the coils inside of it. So they're going to have more energy in it. The energy coming out of the center of your Tesla coil is different than the energy that's coming out on the number 2 winding. That's one of the coolest things ever, guys. Right there. So you see the wire, you clearly see it on the screen. You clearly see that the light's still running. I mean, so we can see that it's going on. So can I do it with other coils? So you may want to know, hey, if you have another, say, a bifilar coil, can I do it then? Well, yeah, I can. So let's go ahead and we'll take this one down and we'll go to the next one. I'll share that one right now. I was asked to see if I couldn't find resonance in my bifilar coil. There it is right there. I got a 12-inch bifilar coil, and I only have it connected to one side, and that goes to this white wire. This white wire, as you can see, is just right there. It's hanging off. I'm going to move this over to my Tesla coil. Sorry, I'm getting tangled in the wire. Now, all I'm going to do is turn this on, remove this light over here, get set up, and then I'm going to put the wire down the Tesla coil. Sorry, give me a second. Right now, it looks fuzzy again. Let me just. I was asked to see if light's not on. Here's our wire. Place it down the Tesla coil. And there we go. Okay. So now, remove the wire. Still has resonance in it. It's dying off. You can see it getting smaller. Yeah, there we go again. We'll do it again. Wires down the Tesla coil. Lights on. Wires out of the Tesla coil. Light's still on. It's going down. The winding is exactly the same inside and out on that bifilar coil. It's no different than the rodent coil. Now it goes out. Okay. Again, we're on. Wires out. Still resonating, went down. Okay. So we're getting resonance in it. Let's see if we can get a distance now. Now we have a light set up from it, and this right here, not too far off. We're probably about 14 to 16 inches off of the coil. So I guess let's see what the. Just a quick spoiler. I don't want to waste your time on this. You do not get breakout on that coil. It's not designed that way. It stays in the coil. I do want to show you this other part before I move on to one more to show you. The backlash on this thing is, look at that. It gets dimmer as it goes down in. Right there. That's what I want to show you. What's going on here? Now I have no heat going in that coil. That's the trick, isn't it? You get it down far enough, it's no longer pulling it in on the breakout of the end of it, right? Now where it's pulling it is from the entire wire. Now I no longer create heat down the center. I'm now creating it cold. That's the point. That's another little trick right there. Another thing that it's doing. I'm changing the capacitance of my coil, and now I'm taking from the center where I magnetically pinch it. It's so cool. It'll still turn the light on just fine. In there. Bring it back. Lights up. Dims down. Now, with that right there, that's how much it's lighting up. And no breakout. Bring it up. Got more breakout. No breakout. Lighten up. Man, that's so interesting. Huh. I can't. So, what's going on, Ben? Anyway, guys, way cool experiment. It kind of tells you that the center of the Tesla coil is more important, but it's also telling you something else. Energy to the center, more important. Magnetics, important. Got to start looking at this kind of stuff, guys. This is the next level of your Tesla coil. You think it's just a sparkler. It's not. And Tesla didn't use it as a sparkler. So let's go on to one more. So go ahead and drop this one and give me a second. Let me grab the other one. Okay. Found it. Give me 1 second. This is my Tesla coil, and it's connected right here from the number 2 winding right here to this little white wire. This little white wire, you can see, it's just an empty end. I have right here my other Tesla coil. It's running on a Slayer exciter at 22 volts. And I'm going to see if I can't light up the light bulb next to my other Tesla coil just by putting this wire down the center. Here we go. And there it is. Right down the center of the coil. Right there, lighting it up. So now we see this in a little different way. We now have a coil that is made to put the energy out, right? It's a Tesla coil. You want to put the energy radiant in the air. It's now putting it out. What does that also mean? Now that I put the energy out, if I put a wire down that Tesla coil, I'm going to be able to pull energy out of it again. Pretty interesting, right? I mean, it's all an experimentation, guys. All I'm doing is showing you another way to pull power out of your Tesla coil. Now, what the crazy thing is, it improves the amount of power in your primary Tesla coil. So you saw the wire going down, right? It's all going down the throat. And you see this little whirlwind thing, right? Like this. So it's getting bigger, right? What is that? It's by doing that, it's changing the energy level of your primary coil. Just understand that. What do I get out of it? Well, the crazy thing about a Tesla coil you got to understand is when you get past 4 feet in a Tesla coil and you put a bulb out there, what starts to happen? The energy level will stop putting out radiant energy and it'll start making your breakout bigger, right? So you have a finite point there. How do you change that? By putting the wire down the center of the Tesla coil, you can now get your distance longer in your radiant energy without getting the breakout. That's the understanding there. We're able to change the Tesla coil. So now I can get to 5 feet without having it break out and ruin my radiant energy. But like all things, man, there's certain tests that you do after that that'll change that. So it's an interesting fact of how this Tesla coil is working and what we're getting out of it. I just wanted to show you guys when I start talking about my gravity flyer, and I want to talk about the Tesla coil and why it's so important. It's this one simple fact. I run the wire down the center, but I do it in reverse. So instead of running it straight down the top, I'll just run it through the bottom. And that's it. And I'll put it up at a certain level. I can run just a rod through it. You can see the Tesla coil right behind me. There's a metal rod that runs out of that. Well, I stick that into the ground. And I put my Tesla coil on top of it. Zero breakout. But I'm able to put in energy to it, right? What happens when you put energy into the ground? Well, we can see from a Tesla coil that when you plug in the ground wire, what happens? You get more energy into your Tesla coil, right? So we know there's energy down there. Now, I'm going to play with how I pump the energy in the ground. We know it comes up. We know that our Tesla coil will pull it up, right? Well, what happens when I reverse it and push it back down? Now I'm playing with the up and down of the power inside the ground. I'm now pumping the earth. So now it changes my Tesla coil again. Guys, this goes back to Tesla's Colorado Springs and what he was doing there. And it's why the next test is important. So I'll tell you about another test real quick before I get to that one. I took my Tesla coil, the same one you saw in the video, and I put saran wrap over the top of it. So what does the saran wrap do to it? Well, it changes my Tesla coil a little bit. It'll push out more energy and it'll make it hot. So I had my power source about 2.5 feet away. And normally about 11 volts, you're not touching that power source. You're not going to mess with it. But when you cover the top with that saran wrap, just the top, okay, just like putting a condom on the top of it. Okay, what happened? Well, the energy level of the radiant energy increased and it brought more heat to it. So now we're getting that energy that pushed out further, and it took my aluminum power source and it made it scalding hot. So again, change my Tesla coil again just by doing something simple as putting saran wrap over the top. Now, anytime you go to mess with the saran wrap over the top, just understand that your number 2 coil is going to break out and shock you. So don't do it when it's on. But now you can understand this. Another fun fact about putting the thing down the center, or the wire down the center. Guys, you notice I'm holding the wire. I did it with a bare rod. As long as you don't touch the sides, you're not shocked. You touch the sides, and it's like that whole game we used to play with the little guy where you put the little tweezers down there and try to get parts of his body. Yeah, that game. That's exactly what you're getting when you're playing with the Tesla coil like that. So best thing is shove the rod in the ground and don't touch it at all. But I just kind of want to touch on this because my next experiment that I'm doing this week has to do with water. And as I put the rod down the Tesla coil, I'm going to put it into water. So all I'm going to do is take regular water from the sink, nothing special. I'll put it in a Pyrex disc. I saw Archangel doing it, so I'm going to do it the same way, but I'm going to use the power of the center of the Tesla coil. And I hope I get an awesome result out of it. So what the thing is I'm going to take one Tesla coil, take the wire down the center, put it into the water. Okay, I'll tape it off so that it doesn't contact the sides and mess with the glass. Then I'll take another wire, put it in the water, and then I'll run it to my number 2 of my other tester coil. And I just want to see if it's going to work. And you may say, well, yeah, it's water. It's conductive. It should work. If you're pulling energy out of one coil, it'll work in the other. Well, prove it first. That's a good step. What's the second step? Throw dirt in it. Throw dirt right in that water. And I'm looking to make a mud pie. No, I don't want to make mud patties and pancakes like I did as a kid. But I do want to be able to take that energy and put it into a solid thing. So we'll put it in the mud when it's wet. See if it still conducts. Now, if you could pass that test, we go on to the next one. We just simply leave the wires on it and let that mud harden up. If it conducts again, well, we've pretty much proven our experiment. Now, some people are going to say that the glass is going to be able to do something about that. So we'll have to run it in different things. If I can find some plexiglass, I'll do it. And I'll run it in there too, just as a control test. I think that would be acceptable at that point. We'll do a little control test with it. And then Joe had mentioned, let's freeze it and let's look and see where the cavities are. And the interesting thing about a cavity is if you take your coil and you put it in mineral oil, if you do not pull out all the air bubbles, what does the air bubble do? Well, it makes a cavity. What does a cavity do? It produces heat. When that thing produces heat and it touches your wire, it automatically throws more amps into your system and starts frying other wires around it, because the coating that's on your wire, when you run something like that, will actually start to burn through because it's not high temperature enough. So we're going to find out if the cavities give us some heat that can be turned into amps. That's going to be a cool test as well. Guys, I'm going to prove out Tesla's Colorado experiment when I do this. I also know by putting just a simple piece of granite in water, I get conductivity. I can pull the granite out of water and get no conductivity. Why is that? I don't know. Maybe it's just a high mineral content. Maybe that's all it is. But it's still something interesting. So if I run into a problem with the water, I'm just simply going to take some pieces of granite and put it in there and bring that conductivity level up and run it again. So I just want to show you guys that there's some kind of an evolution of what's going on. And I'm sure a lot of people who have Tesla coils are going to start to do this. So when I start telling you about my gravity flyer, and here's the connection to the gravity flyer, why I'm showing this, because I can't get people to understand it. When I take my wire and run it straight through my Tesla coil, okay, just straight through. I don't hook it to anything. Just put it straight through. And I can connect it on one side of my gravity flyer. Then I can connect it on the other side of my gravity flyer, and it goes down the other side. So it just makes a loop. Both sides make a loop to my gravity flyer. What happened? I'm using my gravity flyer as a capacitor right there. I'm building up energy in it. Now, how can I build up more energy? Double grounding. Double grounding builds the energy in the ground as a capacitor. Then it's pulled out into the gravity flyer. So how do I multiply the energy in the gravity flyer with very low voltage going in? Well, the answer is real simple. I create a giant capacitor. That's what I'm going to do. I can now pull energy out of the ground as a capacitor and now amplify the energy going in. So how much energy do I need? Well, how much energy can I create? That's kind of the thing there. You tell me it takes 1,000,000 volts to lift it. Well, maybe I can create that. But maybe what we should learn as well, when we're looking at the gravity flyer, it's not working on just little voltage, guys. It's working on how voltage actually works. And that's kind of one of the things here that you got to understand. You want to create a dielectric between the top and bottom plate. Saturation is going to happen in the center plate. When saturation meets the cold energy of the ground, again, the energy in the ground is cold. That's what Tesla was proving out. You can walk over top it, no problem. Put a light bulb in the ground and it'll light up. Guys, that's another test I plan on doing. You're going to see me with these long light bulbs, putting them in the ground, and I'm going to walk like an old man. I'm going to put it in the ground and watch it light up. You're going to start to see how this is going to work. I'm going to use the ground as my capacitor. In that gravity flyer, I could pull as much energy as I need without the heat. Why do I not want the heat? Every time I have heat, it uses my energy. Every time I have it cold, it doesn't use my energy in that way. It allows the energy to percolate around the system because the Tesla coil itself creates a field that things sit inside, okay? Creates the outside field. Then you take a almost static electricity, but not quite. It's a scalar. You take that scalar energy and it'll hold it in. Now, everything that has to do with heat will come out. Everything that's inside is now cold. I have now changed my system. It will run hot on the outside, cold on the inside. I am now playing with the heat of my system. That's the beauty of it. That's how you start to get to anti-gravity. You start to make this thing electrically identified with the Earth itself. That's why it's important to do the Tesla coil experiments. For those who have never run a Tesla coil or gravity flyer, man, is that a hard lesson to learn. It's the answer to what it's doing. So, will you eventually be able to take that out of there? Yeah, once you can create the energy of the Earth, you can. Yeah. Once you can get enough capacitance in something, yeah, you can. But you're going to have to learn it first. So, that's what I say about that, and it has to do with the Tesla coil, and I'll try to prove out the stuff so you guys can see it. So in a way that you could see it. So the way that you would understand it. So it's not always going to be something that, you know, you may click on right away when I start telling you about my gravity flyer. But as I'm showing you these experiments, hopefully you're able to see, hey, hold on. He's getting energy out of it. He's running secondary coils out of it. The Tesla coil is designed that when you put it into the ground, that you're pulling energy out of the ground to give it a higher value of energy coming out. That there's no joke about that, guys. Anybody's run a Tesla coil, if you haven't grounded it, try it. Then I made a bulletproof circuit, man, for a Slayer exciter. As long as it's under 40 volts, man, that thing is like bulletproof, okay? That thing is amazing. I can put it through some really nasty stuff, and it still works out and works every day. I don't have them blowing up MOSFETs. I don't even use MOSFETs. I use a PNP transistor. Totally different thing. Totally different. So anyway, hopefully you guys understand that. Yeah, distilled water. I saw that. I did see that. Okay. Has fluorides in it. Well, the crazy thing about California is they put fluoride in the water. So, and it has electrolytes. Yes. We're going to get that out of it when I use my tap water. California chemical process to filter water has fluoride in it. But one of the chemical processes, by the way, is fluoride to granite is what makes it conductive. So just understand that too, why Tesla chose in Colorado to do things on a big granite deposit. So, and then he ran it into seawater. So maybe salt's a factor as well. That'll have to be decided later on. But I know the steps to get there, guys, for that Colorado experiment, and that's what I'm going to get to first. Then we're going to get back to the gravity flyer, because now that people can understand it, when I start talking about it, now they'll get the idea of where I'm going with it and why I did, and the results that I got out of it will be more understandable. So anyway, I just thought it was pretty cool. For the guys who didn't see it, we covered a couple channels today. In the beginning, go back and watch those if you will. Those guys are really cool and they do good work. So I really do appreciate that. But stay tuned, guys. I'm going to start messing with this Tesla coil in a big way. And it's really going to change your understanding of why we use a Tesla coil instead of the common, let's make a sparkler. I have zero interest in making a sparkler. It's nice. I've done it. Okay. I may blow up one of Ben's apples with it. Because he keeps showing that apple thing without exploding an apple. But as far as why I want to use it, it has to really do with the anti-gravity aspect of it. Because I know what gravity is. And it's, guys, it's really not that difficult. It comes down to a sphere inside of a sphere inside of a sphere, and then you're making charged parts of it. That's it. It's creating a centralized charge. And in every layer, it picks up more and more and more energy till you get to the outside layer. And we are sitting on a plane that is between the anode and the cathode, and we're on a plane here. So anytime you have electricity, what happens? It starts to filter up past that plane first, then the electricity strikes it. So what does that tell you? It tells you there's a center plane that we're in between the anode and the cathode. It's a really simple understanding. The problem I have with people that understand it is they don't understand the states of energy. So if I tell you that it's going to spark out at one part, right? When I put two, let's say a DC flyback, and I put the two anode and cathode together, right? Close up, they're going to spark. I'm going to start pulling them apart. What's going to happen? I get to an area, it feels like there's nothing. I get to an area right here where it starts to create a field that goes across it. Okay. Pull a little further, get that area of nothing. That's where I want. That's my scalar right there. That's what I want. Put a little closer, I'm going to get that field. Put a lot closer, I get short. Now I understand where I need to be. Right here, when they're pulled apart and you think nothing's going on, even when you turn off the lights, you can see that other field when it's a little closer. You can see it coming across, right? Plasma channel uses it all the time. I don't want that. A little bit further. I want this right here. I want the dielectric field. That's the field I work in. That dielectric field. That right there is your scalar field. Most energy in the world can be produced out of that scalar field. That's what I want to use. So I don't want to waste my energy by producing light. So just so you understand, closer you put it, the light changes. It'll go to a pink, it'll go to a white, it'll yellow, all of it. The more closely you put it together. Further you pull it apart, the more purple it gets. Then you get a state where you'll not even see it. Even when you turn off the lights in a regular experiment, you won't see it. That's the point you want to get to. That's the part where now, if I put something in the center, I can now saturate it. But remember, it's like putting a screwdriver in the middle. You'll have to pull them apart even further. Then it uses the center as a center divider, and it'll connect the energy to the center as you pull it out, and the center saturates. That's the point here. We need a point of saturation. And I have to keep it cold. If you do not keep it cold, you're wasting the energy. So if you put your magnets too heavy of a magnet, too many gouts, what happened? Heats up that center plate. What happens when you heat the center plate? You use all the energy. You'll never have energy build up as soon as you do that. That is one of the main things here. You do not want to use that energy like that. You need it to fill a field. So, saturation, pull it apart, fill the field. That's it. Simple as it gets. Then we're going to pump it to the earth. The earth's going to pick up a beat frequency and put it right into your gravity flyer. Now we have something that's talking to the earth. Now I can move within the earth of the energy field of the earth with as much weight as I want. That's the understanding there, guys. That's really what we're trying to achieve here. So it's important to understand what a dielectric field is and why it works. Go read Steinmetz and you'll have it. So for those out there who still want to use the ion wind, it's a waste of time. It literally is a waste of time. I've created project guys where I can get pounds of force on a scale, no problem. I'm not getting grams, getting pounds of force. Why? Because I know how to multiply it. I know how once it's built, when I can get to that scalar field, now I can multiply that scalar field. Basically, I could take a non-conductor and make it into a semiconductor and have it apply force. That's all I'm doing. And I've showed it. It's my little paper lifter experiment. It's not like I didn't show it. I showed exactly what it was doing. So, if we want to put things on the scale and see if they push it underground, if you believe that's anti-gravity, well, I can do a lot of that. I can produce, maybe 3 pounds out of it. If I really truly sit there and build it and build it and build it again, I can perfect it that way. But that's not anti-gravity. Anti-gravity is working within the Earth's gravity and the Earth's field. Every single planet has its own field, and every single one of them runs different. Once we get to the level where we can do it, we can see what that field is. Then we can produce it in a craft that creates that field. Then we know how to create it for each planet. We just got to figure out what the field is of that planet. That's pretty easy. So it was easier than doing this from scratch, I could tell you that. So, guys, there's a different understanding here, and hopefully you guys get it. It's all going to come out soon, and we're going to all understand it. But if I don't show the experiments to get there, and you look back on it, and you want to ask the question of why is it working, guys, I don't know what else to tell you at that point. I'm going to show you everything, and then you'll find out. And no, I'm not using a helium balloon as anti-gravity. It's a much different process, and it has to do with the Earth itself and creating the gravity. So, and then we'll see what happens from there. So anyway, guys, thank you guys all for watching today. I really appreciate it. Hopefully you learned something. Hopefully you'll take your Tesla coil out and do some different things with it and learn some stuff. I'll have a video out probably in the next week or two on the testing of the ground stuff. Try to make it a little more professional in the way that I do it. So it could push out a little further and everybody understands it before anybody tries to clamp down on me. So anyway, guys, thank you very much and have yourself a great day.